Let's solve a problem together. We want to write a program that takes an int array and does the following to each element in the array, but without using any loops. This will be a fun challenge. We want to add 5 to it, multiply it by 3, print it to the terminal window, and finally subtract 4 from it. Here's the array we're going to start out with, 3, 7, 2. Let's start by filling the array. Here we declare our new array, we're going to call it XYZ, and then we go and we give each compartment a value. Since we can't use any loops, we have to just code it all in a top-down approach, which will be pretty long. Here's what it would look like. Alright, so we're going to access each element of the array. We're going to add 5, multiply it by 3, print it out, and then subtract 4. 3 times for each element. This will print out 24, 36, 21, and we will be left with an array that looks like this, 20, 32, 17. However, this solution is very redundant. We have the same code written over and over again. Instead of writing this code top-down, let's use a method to make our program more compact and elegant. Here's the same program, but with a method. Let's go through it together. Here we have our new method that we've called calculate. We've grouped all of the calculations together into one method called calculate that exists below the main method. So see, we have our public class practice, our main method. The main method ends with a curly brace, and then we start our new method right below that. The syntax for our new method looks similar to the ones we've seen before. Start off with public static, include the type that the method returns, in this case, an int. Here we have the method name or identifier, which we've called calculate. Here are the parameters that the method takes in, which is just one integer, which we will call int a, but we could call it anything we want. Then we have our statements that we want to run, and then we have a return statement that sends back data to the original method call. Instead of void, we have int, because this method returns an integer. This method also accepts parameters inside the parentheses and has a return statement. Instead of setting the first array element to 3 and then performing the calculations to find the new value, we just send the number 3 down to the calculate method. So here we are accessing the first element of our array, and we're setting it equal to the results of sending 3 down to this method. So this 3 goes down here. Int a is set equal to 3. Then we run with a here. We do all of the calculations that we want to it. And then a is 20. So 20 is returned and then saved into this array right there. Then we do the same thing, but for the second array element. So we have our second array element here. We're going to set it equal to whatever comes back when we send a 7 down into this function. So calculate 7, int a is set equal to 7, then a is 12, then you multiply it by 3, and a is now 36. We're going to print 36, subtract 4, a is now 32, return a. A is 32, so we take that 32 and we save it right there. We repeat the same thing again for the third array element. We send a 2 down to the method. We calculate what a is going to be, which is 17. We send that 17 back and save it right here. After this program runs, we have an array XYZ that looks like this, 20, 32, 17, which is exactly the same results we got with the top-down code. However, our new code is much more compact and elegant. It's always a good idea to use methods in your programs, especially when you have sections of code that need to be repeated. Let's analyze the scope of various elements in the program we just wrote. Let's identify the scope of the XYZ array and the int a variable. The XYZ array is only visible inside of the main method, shown in the red box below. So we declare the array here, we can access it inside the main method. However, we cannot directly access array XYZ from the calculate method, so not down here. For example, the code below would cause a compiler error. So see, we've tried to modify this array down here, That is not allowed, since the calculate method cannot see variable xyz. It's outside of the scope. The int a variable, here, is only visible inside of the calculate method, shown in the red box below. Int a is declared as soon as the method is run, and then discarded the moment the method is finished running. For example, the code below would cause a compiler error. If we try to print a up in the main method, that's not allowed, since the main method cannot see variable a. It's outside of the scope.